Homework Examples 1.5. The first type of problem is to graph an equation. The way you're going to do this, the way we're going to do this is to make a table of values. You're going to start with 0, 1, 2, 3, and 4. Then you'll find your y, which is also your f of x, by plugging these numbers in for x. So to get this one, I would do 2 times 0 plus 4. 2 times 0 is 0 plus 4 is 4. So to get this one, I would do 2 times 1 plus 4. 2 times 1 is 2 plus 4. Which equals 6. Then here we would plug in 2 up here, so we would do 2 times 2 plus 4. 2 times 2 is 4, plus 4 is 8. Then 2 times 3 plus 4, 6 plus 4 is 10. Then 2 times 4 is 8, plus 4 is 12. Then I look to see how high I have to get. I need to get to 12. So I have 1, 2, 3, 4, 5, 6, 7, 8 spaces. So if I counted 2, 4, 6, 8, 10, 12, 14, I can get my numbers as high as 12. Then if I go 0, 1, 2, 3, 4, 5, 6. Okay, so at 0, it's at 4. At 1, we would be up 6. At 2, it's up 8. 3 is 10. 4 is 12. So we can see 5 would also be here, and 6 here. And I take a ruler, and since this is a straight line of points, I would connect the dots. Example 2. Make a table, x, y, which is also f of x, 0, 1, 2, 3, 4. Okay, so 0, we're going to plug 0 in for x, so that would be 3 times 4 to the 0. We have to do exponents before we do multiplication, so we do this piece first. 4 to the 0 is 1, times 3 is 3. Okay, to get this one, we're going to do 3 times 4 to the first. So 4 to the first is 4, times 3 is 12. Then we're going to do 3 times 4 to the second. 4 to the second is 16. Times 3 is 48. At this point, I'd probably get a calculator out, because then we're going to do 3 times 4 to the third. So I go 4 to the third power, and then times that by 3, and I get 192. And because these numbers are getting so big, I'm not going to do the fourth one. So I need to get up to 192. So I look on my graph here. I'm only going to go out 3, so I'm going to put my axes over here, like this. So this would be 0, 1, 2, 3, and I need to get to 192. So I need to count by something that will get me that far. So I could go 25, 50, 75, 100, 125, 150, 175, 200. So 25, 50, 75, 100, 125, 150, 175, 200. And 0. So now I can graph my points. So at 0 it's up 3, so just be right there really close to the edge. 1 is up 12, which would be about halfway to 25. 2 is up 48, which is pretty close to 50. And 3 is up to 192, which would be up there. This curve, so I can't use a ruler, so I'm just going to sketch in a curve. And that is what we call an exponential graph. Exponential function. Okay, this one. We want to match the graph with the correct description. So we have the amount of water on the grass with regular daily watering in the morning and an occasional rainstorm in the afternoon, and the number of coins in a piggy bank where the person puts coins in fairly regularly and takes coins out on occasion. So the amount of water on the grass, that's going to be a continuous value. There's always going to be a little bit of moisture on that grass. So it's going to, let's say this is the morning right after watering, and then it dries out, and then they water, and then it dries out, and then they water, and then it dries out, and then they water, and then it dries out a little bit, and then we have an afternoon thunder shower. Dries out, water, dries out, water, dries out. So this graph would match with the first description. Here's number of coins, and see this is discrete, so there's this many coins in the bank, and then you add some coins to it, so now there's this many coins in the bank, and then you add some coins and there's this many, and we went a longer period of time before we added coins, and then there's this many, and then we added more coins, then we took some coins out, then we added more coins, and took some coins out. So this graph would go with this description right here.
Hello.
So now we would say that this is a discrete graph, this is a continuous graph, and now we need to label. So this would be time, and this would be water on the grass. This would be time, and this would be coins in the bank. Okay, so C is linear because it's a straight line. There aren't any exponential. Exponential would look like this. That would be exponential. Discrete. B is discrete, and A is discrete. Continuous. D is continuous. C is also continuous because there's no breaks. Increasing. C is increasing. Decreasing. A is always going down, so it is decreasing. Okay, solving for x. We can add 2x, 3 equals 6x minus 8, add 8, 11 equals 6x, divide by 6, x equals 11 over 6. Okay, now this one. Add 14 to both sides. 5 to the x equals 125. So now the question is, how many times do you times 5 by itself to get 125? So you think 5 times 5 is 25, times 5 is 125. So there are 3 5s, so this would be 5 to the third power. So x equals 3.